Good everyone. Super glad to be here. Giving a talk on build a secure facial voting application with AWS Serverless. Like you mentioned, my name is Chibuike Nwachukwu, and let's begin. So you asked, what prompted this talk? What made me come with this particular topic? So sometime in 2023, around February, I was in between roles, right? And I happened to hop on the AWS Reinvent, this YouTube channel, the event page, and I saw a talk by James Beswick where he was talking about building serverless presso. Now, at that point in time, my previous engagement, I worked for a US company that really invested a lot on migrating a particular monolith application to microservice serverless in AWS stack. But I really needed to see how I could do this, but outside of work, since I was in my break period. So I used this particular talk from James Beswick to really understand and really go fully into event-driven architecture and also the whole serverless space. So like I said, serverless presso is the inspiration behind the project and the talk for today. It is a event-driven coffee application. If you are opportune to go to either perhaps AWS summits or even reInvent, you'll see it's actually in practice, how it takes orders and all that. So then, how could I go from this particular coffee application to something that I could actually relate to, right? I wanted to learn, but how could I connect it? At that point in time, February to April, in my country, Nigeria, we were within the election period. So that was the best opportunity to practice, bring it back home, because they always say the best way to learn is to build something that you actually understand, right? So I'll go on to have this particular voting idea. How could I revolutionize this voting culture, right? How could I add AWS stack to it to make it a bit more modern? And what I was actually looking for, like I said, serverless presso was the inspiration, was first of all, something I could relate to it, something about to do with serverless stack, right? And also event-driven architecture. I wanted to learn a lot about this whole event-driven architecture. I've done it a bit at work, but I really wanted to do a project that I owned from start to finish. Also, at that point in time, all I knew about serverless mostly was DynamoDB, Lambda, but I've not really seen orchestration, in terms of how step function works. I've read about it, but I've not really done it in a project. So I really wanted to use this project to learn how AWS does orchestration, especially using step function. And not only that, the actually goal was that when we build applications, we should actually think about best practices and also security. So how could I embed security to every layer from both development stage to how I deploy it safely to AWS cloud, and making sure it's also going to be very cheap and also scalable. And we all know how and love how serverless is scalable and cheap, right? So I'll go on to build what I call serverless facial voting application, which I termed FacePoll. So I started building it around April 2023. It took me about 3 weeks, I think about 5 days to 6 days to architect, to come up with architecture, and then 2 weeks to build the project from ground up. So what exactly it does, if you can see the image from far, it allows users to vote with their facial features. So basically, users upload take a selfie and then upload the face, and they kind of register it in the backend. And then so when they come back next time, they don't need to have an ID card to show. They just take a selfie, or this camera scans them, and then they can safely vote. So what exactly does FacePoll does? So the first part, like I explained, it allows users to uniquely vote with their face. So we don't want different users having the same profile. We don't want even identical twins voting for the same profile. So we wanted people to be able to identify based on how, using face basically, unique faces. Also, like I said, once we register a particular face, when you come next time to vote, we want to authenticate with your face. We don't want to do a card. We don't want to do paper voting. We wanted to make it a bit more secure and a bit seamless by having your facial features to authenticate. And also securely cast your vote. We'll go into details in terms of how security works for this project, but just have the idea that not only should the user be able to vote, but should be able to have it vote securely, right, and not have data breach along the way. One important feature I saw in serverless presso was the ability to have real-time updates. So you have the baristas taking orders, and people are ordering at the same time, and you're seeing it happening on the monitor. You're seeing your step, you're seeing the particular order that's coming through. So how could I bring this within my own project to make it so users can not only see current or past results, they can also see real-time results as they come into the application. I've talked about cost effectiveness. So I'm going to show two main architecture, but ideally I have three architectures, right? The first part is the admin section, which we'll not really go into, but this main part, which is the first architecture, is the facial index flow, which I call the registry, when you try to register a particular face. I'll go into details into that as I go within the talk. The second architecture is the facial recognition flow. This happens when you try to vote with your face, right? This whole flow is what happens. I'll also go into details within the talk. So who am I? Like I explained, I'm proud Nigerian. So fun fact, it took me roughly 10 hours from Lagos, Nigeria on Tuesday morning to like reach Manchester. I work as a full stack engineer at Micro One. So basically, Micro One is a consulting company that allows connects foreign workers to US companies, right? So you work for them, and they employ you like US companies. In 2021, I became a bit tired about always coding behind a laptop. So I decided to take off a new challenge, and I'll enroll on the course on a culinary and chef class for like a year, and I'll officially become a certified chef. Unfortunately, I didn't add most of my pictures there because of this number of slides, spaces, but just now I'm a certified chef, right? And in a bid to constantly learn, I started my certificate journey in 2022, not just to get certificates, but to actually learn how I could use best practices. So I made sure that whatever I was learning, I was building projects, and I was also writing. And that will lead me for like 2 years, 4 months, and I will get fully certified and get my golden jacket, I think around November last year. And you try to find me often speaking, traveling, and giving talks. I kind of find it very interesting to like visit multiple countries and then also write articles and share my knowledge. So the agenda for today. So I've seen what prompted this talk. We've seen why this talk or why this project actually came forth. Next, we'll see the register voters flow in details. We'll review the architecture. I also see each component in view. Next, we'll see the voters flow, what happens when you try to vote. And the next important section is where I try to explain the multiple pillars that make the talk stand out, right? We'll look at real time, we'll look at security, we'll look at data privacy, and a bonus, we'll get to see a fourth bonus later on. And then lastly, I'll show a brief demo, 2 minutes demo, on how the application works, and then next steps that we can go on. So register voters. So basically what happens is that the admin goes at the back, perhaps using Cognito user pool, uploads an Excel file. So this is what happens initially, right? So this is the architecture I was talking about. This is the admin flow. So the admin goes to Cognito, uploads the user email addresses, or they can use a platform I built on front end using Next.js to allow you to still like type in the user email address. And once you enter the user email address, the user is then added to the system. So what they need to do next is to retrieve the account, which is like we have the first architecture that we saw earlier. This same admin can also create what I call categories. So categories are like voting. So if you have like presidential elections in my country, you have governorship elections. These are each categories, and then you can create your candidates under each category, your time slot when you want the voting to start and you want the voting to end. And all using Cognito, API Gateway, Lambda, and the central DB we're using is DynamoDB. So how does it work? So at this point, admin has created users on Cognito user pool, users trying to retrieve the account. So the first step is to enter that particular email address that the admin added for you. You enter your email address, and next you get an OTP sent to that email address. I'm using Amazon SES. You enter that particular OTP, and you click on the validate button. And once I validate that that particular email exists within our record, you can then upload what I call attach your face or tie your face to that particular email address. At this point, Lionel Messi is trying to vote, so you just need to upload his face and click the add photo. What then happens? Like I said, orchestration was a very important section I'll take a look into. And this was my first time actually touching AWS step function. So what happens is that once you upload it to X3, it triggers a Lambda function that starts the step function. Now the first important section is the validate face. This particular step is very important because I didn't want users to upload an image of a cup or an image of a microphone and then somehow start the step function. So this part catches to make sure that the particular image is actually a face. So once it passes that particular task, it goes through the next task of checking, does this user actually exist already on our Amazon Rekognition collection? If the user exists, we're going to bounce them back. If the user doesn't exist, we then try to index the face to Amazon Rekognition, and then we save the index and some other details to DynamoDB. So let me explain this a bit more details. So if you look at the front end is hosted in Next.js Amplify. So the user uses Cognito Authenticate SCS. The next step is to upload your face to Amazon S3 bucket, and then this triggers the Lambda function that then calls the step function to start. Like I explained, validates, check, duplicates. It indexes using Amazon Rekognition collection, and then it saves some metadata to Amazon DynamoDB. If you look in the center, what actually drives the whole event-driven and real-time updates is a very important component, which is Amazon IoT core. So it is the central that allows me to send requests back to the front end and allow the front end to also communicate with the back end. Now, the reason why I have to use IoT, like I said, Serverless Presso, was because we are using event-driven. We don't have like a, a post and response. We are not firing events. So we want the front end to be able to receive unique or specific events that they actually triggered. And this is IoT comes in. Users subscribe to specific topics. So take, for instance, there could be a global topic called all results, and then all users get that particular message pushed to that topic. Or could there be a unique topic called maybe the user email and some other indexes that only that specific user should actually receive to tell them, okay, you are currently at this stage in indexing, we're indexing your face, we're currently at this stage checking for duplicates. So this particular user front end can actually see what's happening on real time. And that's where IoT core actually comes in. So it plays a very important role in this architecture. So I showed a snapshot. So I'm using Node.js for this. I'm also using Serverless Framework version 3 for this as well. So this is a snapshot of just saving into DynamoDB. This is like the last step. I'm also using the single table design. If you're familiar with DynamoDB, I think Alex Debris made it like very popular using single table design architecture. So I'm saving the face, JSK1 and all. And then I saved in DynamoDB, and as I explained, that I sort of push the data to AWS IoT. So that's basically what happens for the register flow, right? So the second flow is the voters flow. So at this point, the user tries to authenticate, and then they should be able to cast their vote securely. So it's quite similar to the first flow. At this flow, we start rather with the image. So the user takes a selfie, and then they upload their image, Messi again trying to vote this time. And next, once the user is found, we get feedback from AWS IoT, and then we pull all current voting that we have, right? So currently we have all FIFA best, and we have like candidates, Messi, Ronaldo, and we then send an OTP to that particular email address that was initially tied to that particular face, right? So the user, this is very important because initially I didn't have this when I did the architecture like for the first 5 days, but then I started thinking, what if someone snaps his face and votes on his behalf? And that would be very, very interesting. So I said, okay, so at that point, we should actually allow you to always send an OTP to make sure even if you snap, you're not going to get the email address. So only that particular user should be able to get that email address. So if you take a selfie, you're going to get an OTP to confirm that you're actually the same person that is actually trying to vote for that particular voting session. So you enter your OTP, and then you click the vote button, and then we start the compare face step function. So very similar. First of all, we validate that you're actually snapping a face, and next we check that that particular face is currently indexed. So if you remember the other point, we make sure the face doesn't exist, but at this point we want the face to exist, right? So once the face exists, we then we do two things, the last two steps, which is like what makes it a bit more secured. The third step was added, like I said, later on, whereby I send an email OTP to the email address attached. But the third or the fourth stage is what allows me to, what I call, have a secured voting process. So I generate an AWS STS token that expires after 15 minutes. And this is very important because when the user tries to vote, we are securing the APIs using API gateway using two formats. We're using API keys, also using IAM authorization, right? So this STS allows us to use AWS Signature 4 version, That's like how AWS authenticates their APIs. And then we pass this STS token to the API gateway so that the users can combine the API. Basically, when I say user, so I mean Next.js application, can combine the API key as well as the STS token converted using AWS 4 to be able to authenticate and vote securely. Yeah, so again, let me try again and explain the architecture. We all know how it works. So amplify again, first of all, it goes to S3 bucket. This initializes a Lambda function that triggers the compare face step function. So it does the validate, it does the detect face, it does the send OTP, as well as generating STS. And we send it through AWS IoT, be it success message, be it error message, be it any other data we need the front end to have. We use IoT as our hub in terms of like translating and pushing data back and forth. So once we get that particular STS token back to Amplify, we also assume at this point the user has gotten their OTP. So then they try to vote and they click the vote now button, they select the candidates and the voting session, and it hits the API gateway and it goes down to add vote Lambda function, and then it adds straight to DynamoDB. Now what makes this real time is DynamoDB has this feature called DynamoDB streams. I don't know if you have worked with it. So this allows us to capture what I call data capture as the actually data enters DynamoDB, right? So I use this particular feature, again, taking inspiration from Serverless Presso, to track once data comes into DynamoDB. So I can, at the same time, push it from using streams to a Lambda function and then pushing it down to IoT, who give it back to my front end. So at this point, you have users voting, and then you have a live dashboard, and actually seeing the result in real time. So this is very interesting because it allows us to not have to build or use commercialized real-time databases, right? We can actually have inbuilt custom approach, which is this, to have once it gets to DynamoDB, it goes down to DynamoDB streams, and then I kind of do some little filtering with the Lambda function, and then I push a structured data. So basically, I'm pushing to a particular topic. It's called like all votes, so that all users, both authenticated and not authenticated, can actually get all results because the live page is open for everybody to see. We don't want cheating. So they send it down to AWS IoT, and then Amplify is the last section that actually gets the voting result. This is a breakdown just to look in depth on only the voting section. So Amplify API gateway, Lambda, DynamoDB streams, down to IoT, and back to Amplify. So that's like the first three sections where we looked at why this talk is important, why this project came up. Then we looked into details into how we could register users from facial features, and then we saw how to validate each face to make sure users can vote securely. And then we have a working application at this point. We have users voting and everyone's happy. But then how or what prompted what I call the architecture, because I actually added some more, like I said, I refined the architecture as I saw more bottlenecks along the way. I had friends actually test it and like suggest how they could break the system, and I began to think, how can I actually prevent this? So these three core pillars are like what I would say guided me to make sure I had this a bit secure application. So the first part is real-time security, data privacy, and then a bonus section. But you ask yourself, why did I choose this approach? Like I explained, I wanted to focus a little bit more on security to make sure the project was very more secured. So at every layer, be it from sending to IoT down to DynamoDB or whatever, I tried to make sure I was security conscious. Also, I needed to combine choreography and orchestration. Choreography in terms of how I do event bridge, triggering, S3 and all likes, and then orchestration on how I use step functions to like make the application seamless. And also, I wanted to address data privacy. We'll actually look into this a bit more details, but data privacy in terms of, I wanted users to be comfortable with the data on our servers. And I'll explain how that works a bit shortly. And also, I didn't want to spend a lot of time. Like I said, it took me 2 weeks, which was like one of the fastest development I've done so far to build the full application after I architected it. So I didn't want to spend a lot of time thinking about, oh, I have to do EKS and I have to like figure out some other stuff. I want to just go with serverless and just have AWS handle the heavy lifting for me. So in terms of security domain, we saw how STS comes to play. I also explain how API gateway is secured, not only using API keys, but also secured using IAM. And one interesting part is we focus more on making sure, or I focus more on making sure that functions only have the particular permissions that they need for a particular use case. So the whole concept of least privileges, right? And Cognito helped a lot in this, so I didn't have to do a lot of custom stuff. Cognito has this whole on-auth and auth way of doing things, so you just need to configure the particular permission for each of them. And I also use this whole Cognito auth approach to have users, authenticated users, to upload their faces to their own private buckets. So this is kind of data privacy a bit, but we'll actually go into more in data privacy. But this is the core security tenants or the core security domains or guides that I actually followed in building the application. This is the bonus section. I added it last when I was working on my talk. This is just the facial recognition flow. Like I explained, I use Amazon Rekognition collection. This was 2 years ago before the whole AI buzz, so it's not really following the whole AI buzz. Basically, I use Rekognition collection to store and index my faces, and S3 is used for that triggering. Once a put object API call happens, it just triggers the flow to start a step function. I also explain how I make sure to remove any false positives, so that if you snap a cup or you snap a microphone, it should naturally start the process of indexing your face. And also explain how holography and orchestration actually comes to play, and how AWS IoT core helps in error handling to tell the users, oh, this is particular what happened, and the users are actually very, very surprised to see stuff happen in real time, without having to refresh their pages. And that brings me down to real-time approach. I explained it a bit. I explained a lot, actually, how DynamoDB streams combined with DynamoDB allows us to push data as we capture it as it comes down to DynamoDB. I also explained how I use Lambda to do some filtering and then push it down to AWS IoT core and down to Amplify and Next.js. Now, the data privacy approach. Like I explained, I'm using private S3 buckets, so users who are authenticated have access to different, the same bucket, basically, but different folders, right? So you don't have access to another person's, where the person uploads their face, right? Also, interesting part is that I found out that I don't really need to keep the user's information, right? So once the user uploads their face and I index to the Amazon Rekognition collection, I have no business, again, having their images stored in S3 bucket. So that's the whole concept about how much or how long can you hold users' data. So I had to configure Amazon S3 lifecycle deletion policy for after a day to delete the main image that was stored in S3 bucket, since I have it already indexed in Rekognition collection. Also, like I explained, an afterthought, but a very, very important section, was making sure I had 2FA using AWS SES to allow only users to vote for their particular only users to vote and make sure it's them, sorry. And then private scope data transfer is basically what I try to explain in terms of, if you're using IoT core, there are some times I send, for instance, all results. I want all users to get that result. But there's sometimes I only want to show the progress for a particular user, right? And I don't want it to mistakenly filter into another user's session request. And so that is the whole concept about privately scoped data, to make sure I have unique topics per user at some points, to make sure user only gets the particular data response that is only unique to them. Right, so that's the project in a nutshell. I'll be showing a demo. It's actually a GIF image, so it's not like a video. I didn't really trust demo gods to do a live demo or a recording. I could have done a recording, but it's going to show me clicking a lot of things, so I just did that. So I will explain how it moves. This is a landing page. Now, this admin section, he tries to add the user email using the platform. Now I'm using AWS SCS, so I have to, it's not in production, so I have to add users to so I forgot to call it, and then I get the email confirmation to make sure the users can, it's in sandbox here, so the users can then receive emails. Then the user goes now to retrieve their account. They enter their email address, they click the retrieve account button, and then they have to get an OTP. So the user goes and gets an email, they click on the email provider, they copy the OTP, And they will enter the OTP, and they click on the validate button. Next, they'll have to upload their face, and Messi again will try to vote. Yep, and he'll click the add vote button. Next, this is admin app I built, so admin is going to add the voting categories. If you look now, he has added 2, so he had the best food, and he have like jollof rice and all, and they have like FIFA best, like Ronaldo, Messi. And the user tries to validate, he comes back to upload Messi again trying to vote, and he uploads his face. He clicks on the authenticate button, does some loading, and this triggers the compare face step function. And then this pulls out the current categories that we have with DynamoDB. So the user selects, obviously Messi is going to be voting for FIFA best and not best food. So first of all, he gets the SES I was talking about, the 2FA, and he copies it. And then he selects FIFA best, and I'm very curious to know who he will choose for candidate. Okay, he chooses himself. So Messi chooses himself as the best player, and then he clicks on the vote button. And now, before he clicks on the vote button, I actually went to live results to show what currently is the live result. So at this point, I'm going to pull the current results, FIFA best, and we'll see we have 3. We have Ronaldo having 3 votes, Messi has 2 votes, Haaland has 1 vote. This is like a graph and all that. And so then I'll go back to Messi to click the vote now button. And this should trigger the compare face and then push DynamoDB streams. And then Messi has populated in real time his results. And then we have him and Ronaldo being tied as they should be. So that's the demo in a nutshell. And yeah. So that's it. So I will go into the next. In summary, so what are the lessons I learned from building this approach? I found out that if I went through the serverless or the server approach, it would have been a lot more costly. Fun fact, I think I've not brought down the application. This is like running to 2 years. And I'm not worried because I've not really gone above $20, and I have like a lot of AWS credits. So only where users visit the page and do a lot of testing that actually have to worry about costs. So for now, it's very cheap. I also learned that security should never be an afterthought. I made a mistake in terms of like having 2FA, missing it in the beginning, but you should actually think about it every layer. I thought I covered it all, but as friends like spoke with me, I found out that I had like a loophole in that particular section. One interesting thing I found was I actually used a provider called Lumigo to like do my cloud information with CloudWatch. But then before I used Lumigo, I was having issues with seeing my logs, and I was able to combine Lumigo, CloudWatch, and Step Function to first of all, Step Function allowed me to see data coming in and track, okay, what was exactly causing my issues, because this was the first time I was using Step Function. It was very, very helpful. And then CloudWatch plus Lumigo was able to allow me to catch a particular Lambda function that was running recursively, and I was able to catch it, and Lumigo warned me that if not, I was going to have a lot of bills. And that was a lesson I learned about how important it is to combine all these tools for improved debugging. So when I think about what next I can use or I can do to improve, this is a project I built 2 years ago, whereby if you look at in the architecture, I said S3 triggers Lambda, Lambda triggers step function. But now you can cut out the Lambda function in between and just have S3 trigger step function to start the whole step function. I could also improve, or you could also fork the repo, which I will share very shortly, to like maybe add fingerprint authentication with perhaps the user's phone and inbuilt fingerprint stuff, and also improve the UI. I'm a jack of all trades to an extent, but I'm not too good in front end. I can do some couple UIs, but I'm not too good. So you could actually improve the UI to make it more interesting. So finally, you can see the resources. This is a GitHub repo, and then this is a Medium article I wrote about it. So I'll give like 20 seconds, then I'll move to the last slide. Perfect. So thank you so much for coming to my talk. You can connect to me on LinkedIn. I was so much glad to connect. Thank you.
Okay, thanks very much. That's great. Any questions?
Yeah, great talk. Thank you very much. And you talked about private scoped data transfer. How did you do that? Was that using like a specific like IAM policy or something to?
No. So it's just, wonderful question. It's just a custom approach, basically IoT topics, basically. So it's just to make sure, I explained that I had a topic called all topics, all votes, to allow all users to like get results. And then I had privately scoped, having like the email address and some random string that only that particular user that initiated that request has the same topic subscribed to. So it allows you to only send, so these two can only sync, and we don't want a third, another user to mistakenly get the same message that is being sent. So just IoT topic, basically, that's what happens. Yeah.
Right, so just restricting the specific users.
Yes, to that particular IoT topic.
So did you just have like a few topics or just a single?
Yeah, I had some few core topics. I think like 2 public topics, and then the rest were just random topics, right? But appended with the user email address that only the front end and the back end knew about.
All right, that's really good, thanks.
We've got time for one last question. Anyone else?
Thanks for that. I was just wondering, because you said you used the IoT core to send or allow people to see what's happening.
Yep.
What was the main security? How did you protect someone coding, actually coding and trying to do something that they shouldn't?
Yeah, so I think AWS IoT has inbuilt security. So an Amplify connects securely to the particular topic. So I'll allow Amplify and Cognito to do the front-end authentication connection securely. And also AWS does it from the backend with Node.js. I just need to push to the particular IoT topic. So I believe AWS does that part in terms of security and Amplify for the front end. Yeah.
All right. Thanks very much. Great talk. We're back here again in 8 minutes if you're here for the next one. Well, thanks very much.
Thank you.